This video will explain the PowerPoints for sections 9.4 and 9.5 on multiplying and dividing radical expressions. Section 9.4 was focused on multiplying. How do we multiply radical expressions? We find the number underneath the radical and we multiply them together. 5 times 7 or 7 times 5 is 35. Even if there's a variable, we keep that variable with it. 17 times 14 x is 98x. After, though, we can ask ourselves, can we simplify that any further? 98x. I can break that down into 49 times 2. And this can be a perfect square. 7 times 7 is 49. But that 2 cannot be simplified any further. That 2x stays together under our radical. So 7 times the quantity, 2x square rooted, would be our final answer. So if we're asked to multiply two separate values and we have radicands, then what we can do is we can multiply the coefficients, or the numbers in front of our radical sign. In this case, it's 2 times 11, which gives us 22. And then we can multiply the radicals. So 5x times 2x, well, 5 times 2 is 10, and x times x would give us x squared. What we can do then is ask, what can we simplify? In this case, we have a square. This x is being squared, and we have a square root with that x. So the x squared, the square root cancel out, which brings the x on the outside of our radicand, and we're left with 22x times the square root of 10. We cannot simplify the square root of 10 any further because it's not a perfect square. So let's try that one more time. Multiply the coefficients. So we would have 4 times 2, which gives us 8. Multiply your radicals. 12 times 6 is 72. X times x is x squared. Again, we end up with 72x squared, so we can ask ourselves, can this be simplified into a perfect square? One of the numbers that multiply to equal 72, 36 times 2. 36 is a perfect square. The x and the radicand cancel out. The x comes on the outside, so now I have 36. Square root of 36 is 6, so the radical above this 36 cancels, the 6 remains. Now I have 6 times 8, which is 48 times x on the outside. The square root of 2 is the only number that is under the radicand. Multiply and simplify. 3 times the quantity, square root of 5 minus the square root of x. So if we multiply and simplify this, we would have 3 times the square root of 5 minus, we're going to distribute, 3 times the square root of 5 minus 3 times the square root of x. And then ask yourselves, can we simplify that any further? No, we can't, because these radical signs do not have the same value underneath them. We can't combine this any further. Multiply and simplify. Again, distribute w, square root of w times the square root of w. Then the square root of w times the square root of 5. 7 times the square root of 5. And in this case, we would have the square root of w times the square root of w would be the square root of w squared, which we learned cancels out. Square root and squaring are opposites, so we're left with w. And then we have our subtraction sign stays the same. And under our radicals, we would multiply this 5 and the w would be combined, 5w. And we can't simplify that any further. Multiply. We can also use a FOIL method to obtain 4 products. So what was different? In the last case, we were only multiplying by one term, by a binomial, by 2 terms, right? In this case, now we have 2 terms being multiplied by 2 terms. So we are distributing, but to get even distribution, that's why we have to use our first outside, inside, last FOIL method, and we're following the same procedures as we did before, but we're keeping those radical signs, and we're multiplying if the numbers underneath are radicals. 5 times 2 would give us that radical of 10. 6 times the square root of 5, 8 times the square root of 2, and then we have one number that's a positive 48. And from here, we can ask ourselves, is there anything that we can combine? And in this case, no, because all of the numbers under the radical sign are different. Again, we have two separate terms being multiplied by two separate terms. So we can use our FOIL method to distribute first, outside, inside, and last. But in this case, we can simplify our original answer further. We know that the square root of 36 is a perfect square. That is equal to 6. We know that we can simplify 12 into 4 times 3, and 4 is a perfect square. So that would be equal to 2 times the square root of 3. We could also combine these 12s before we simplify that even further because they are the same value here. Okay. Another example where we are using our FOIL method, but in this case the inner and the outer terms end up canceling each other out. That negative 6 times the square root of 3, positive 6 times the square root of 3, minus 36. Our inner and outer terms would cancel each other out. We do have this 3 minus 36 as our what would remain. And so that would give us negative 33 if we showed all of those steps. And our last section, 9.5, on dividing our radical expressions. If we have a square root of a fraction, it's the same as saying we're taking the square root of the numerator divided by the square root of the denominator. So it doesn't matter how we write it, we can break it down into two square roots and simplify as much as possible. So here are two examples. We can take the square root of 25, which would be equal to 5, the square root of 36, which would be equal to 6, and that would be as far as we can simplify that. Or we can take the square root of 75 divided by the square root of 3. It might be easier to divide these first and say, hey, 75 divided by 3 is 25, and I know that's a perfect square, and that equals 5. So it can work in your favor in both ways. We just have to analyze the numbers first and see which way would be better for you. So in this case, it's better to break it apart. Let's look at y. We know we can take the, 81 is a perfect square. So right away I can say, hey, if I broke that into two parts, I could take the square root of 81 to get 9. And with 75, we can say that would be the product of 25 times 3. And I can take the square root of 25 to get 5. So that would be my final solution. Another example where we can simplify this even further, we can look at 64 and say, what two numbers can I multiply together? This is an even number. And if I did multiply by 2, then I could possibly cancel out our 2's, and I can look at my x powers and also cancel those out as well. So we would break that down into 32 times 2x to the 5th power. 5 minus 3 gives us x squared in the numerator, or x to the 2nd power, and divided by 1 would cancel, because dividing by 1 is not going to change anything. Even if we took the square root of 1, 1 times 1 is 1. So we're left with asking ourselves, can we simplify this further? Yes, we can. 16 times 2 is 32, and 16 is a perfect square. And so that gives us the 4 value here. And then we have our 2x squared and our x squared and the square root cancel, so we're left with just an x on the outside. The square root of 2, though, cannot be simplified any further, so that radical would still be there. We have what's called rationalizing denominators. So if we have a fraction that has a radical in the denominator, or the bottom number, the denominator needs to be rationalized. To rationalize a denominator, you want to change the fraction to an equivalent one that has an integer in the denominator, or a whole number. So let's finish up with some of these examples. We want to make sure we're not ending our answer with a square root in the denominator of a fraction. In this case, the 3 is the denominator and it is a square root. So if we multiply both the top and bottom numbers by the square root of 3, we would be able to make that a perfect square. 3 times 3 is 9, and the square root of 9 is equal to 3. So we can simplify that further. The second example, we were asking to simplify and get rid of that square root of 27x in the denominator. We can first simplify. 27 is 9 times 3, and the square root of 9 is a perfect square, so that would give us 3x. And then if we multiply both the numerator and denominator by 3x, then that would cancel out our numbers in the denominators. Conjugates. When the denominator of a fraction is a binomial with a square root, the denominator must be rationalized. This is done by using the conjugate of the denominator. The conjugate of a binomial is a binomial having the same two terms with the sign of the second term being changed. So you can see the conjugate of 5 plus the square root of 6. We're going to change that sign in the middle and change that to a negative, or a subtracting that square root of 6. And the conjugate, or the opposite sign of subtracting to the square root of 2y, would be to add. And so how we could use that is, in this case, if we want to simplify, we can multiply by the conjugate, and that can help cancel out those square roots in the denominator so that we are able to distribute and simplify to reach a solution. And here's one more example where we can rationalize our denominator, or get rid of the square roots in the denominator of our fraction to simplify our answers. And in this case, we can use the conjugate of the square root of 3 minus 2 would be to add the square root of 2. And that would be our conjugate that we would multiply the numerator and denominator by in order to rationalize that denominator and end with a solution where we do not have a square root in the denominator. 5 plus 2 times the square root of 6 would be our final solution here.